Hi, now I am going to explain about classes. A class is the data type that includes data that is called class properties and function and task that is called methods that is going to operate on data. Okay, this is one example class. Okay. So class is a data type. We are declaring as a class name and we should use end class. Within that we have a properties and methods. So this is called a properties. And task and function which is present inside the class is called methods. So the advantage of class is classes allow objects to be dynamically created, deleted, assigned and accessed via object handle. Okay, we can able to create a handle for accessing this class. Through that we can able to access the properties and method which is present inside the class. Here inside this class I have two methods. One is task. In that task set what I am doing is int I, default it is an input. I am receiving I value, I as argument. I am receiving the value of I and that I assigned to x. X is nothing but the int data type which is a property of this class. Inside this function, okay, using get, okay, the name of the function is get. I am returning x value which is there. I value stored in x, that value I am written with the help of return keyword. So the class is very important in system Verilog because we are going to develop all the test events component with the help of classes because it is dynamic in nature. Okay. So wherever you need, you can create it and we can send the stimulus to the DUT, and after that we can able to delete the object. So those facilities are available in classes. So mostly we are going to dealing with these classes. Now we are going to see how we have to create an instance for a class and what is meant by object creation for that class. The declaration of variable class 1 with the type SV class, or another way we can say variable class 1 can contain a handle to an instance of the class SV class. So this is the way you have to instantiate that class. So this is the instance of that class. SV class is nothing but the name of this class. Okay. So using that I declare a variable. So class 1 is a type of SV class. So this is the one way you can say. Another way, this class 1 is a handle to access the SV class. Okay. Then object creation in the sense. So here it's just a handle. There is no physical memory is allocated for this class. It is a virtual thing. When you view like this, class 1 equal to u of, okay, we are calling the new method which is present inside the class. Okay. So when you call this method, automatically a physical memory is allocated for that class, so that you can able to access the properties and methods of that class. Okay, this we did in 2 lines. So a single line you can able to declare a variable as a SV class, and you can able to create a constructor, new constructor for that. Okay, we are creating a memory for class 1. So we will see one example. Inside this is a class. Okay. Class SV class. Inside that I have a property int x and I have a method task set. Here I am receiving an argument and that argument value is assigned to x. In this function I am returning that x value. Okay. So this is the class we wrote already. Okay. Now inside the module, Okay, inside the module, I am instantiating this SV class as class 1. Okay, now this class 1 is a handle for this SV class, or else class 1 is a type of SV class. Then within the initial block, I created object for that. Okay, now physical memory is created for this class 1. Now you can able to access the methods and properties which is available in SV class. So class 1 equal to new. Okay, here I created a new for this class 1. So this is the another way. I instantiate a class 2 handle. Okay, class 2 is also a type of SV class. For that I created a new here. Okay, there are two handles now, class 1 and class 2. For class 1, I am accessing the set method which is present inside the class 1. So with the help of this dot, we can able to access the methods, okay, or property. So class 1 is nothing but a handle of the SV class. Inside that I want to access the set method, this method. So class 1 dot set of 10. The 10 I am passing here. So this 10 is assigned for x. Then class 2. Class 2 is a separate thing. Class 1 is a separate thing. Here we are creating memory for class 2 separately, class 1 separately. So one particular memory is allocated for class 2. It consists of all these methods and properties. And for class 1, separate memory is created. Inside that also it consists of all these methods and properties. So here I am accessing the set method which is present in class 2 and I am putting 20. So instead of this side, value 20 will assign to, from here it will assign to x value. Now x is 20. So here in display statement I just display accessing the value of x with the help of get method. How I can access this get method? Class name class 1 dot get. So this will be called, so it will return x value. Let's check in output. So first for class 1 I am getting 10. I put 10. I set 20 in class 2. Here I am getting 20. Okay. We are going to see the keyword this. So why we are using this keyword means, this is one example. Okay. Class packet, inside that we have two properties A and B for byte type. Inside this function name is set data. Okay. Byte A comma B. Here I use a same variable name here inside this function. Okay. And now I am assigning A equal to A. I am getting A value and I am plan to assign the getting A value to the existing value A, which is present inside this bracket. Okay. So but the compiler will not able to recognize which A is local to this function and which A is the class A. Okay. So that you will get its default value. Okay. So to avoid this, we are going to use this keyword like this. Using this keyword to solve this issue. This dot A. What it means this indicates the variable which is present inside this class. So this A indicates this one and this B indicates this one. So that this A value, this received A value is assigned to the variable A which is present inside this class. So you should write like this dot A equal to A, this dot B equal to B, when you use the same variables as an argument. Okay. Okay, now this is the class name packet. Inside that we have address, data, write, packet type. So these are the properties of this packet, and here I write a new constructor. Okay, so I already told when you call new of, memory will be created for that class. Okay, so this new method will be defaultly available. You can able to override that by writing explicitly function new, okay, and end function. Inside that, whatever you are writing, that will be called when you call new of here. Okay. So here I declare here these are the input arguments I am getting: address, data, bit write, and then string, packet type. So those things are whatever I am receiving here, that I am going to assign this address. To this address I am assigning the received address. Okay, the data which I am receiving is assigned to this data, okay, for this data, and write, that is assigned for this write. Okay, and I wrote a separate function to display the values of address, data, write, and packet type. Okay, this is just a function. When I call this display function over there, automatically it will display all these values. Then inside the model, I instantiate the packet with this packet with the name of pkt. Okay. Then within the initial block, I am calling new of. Okay. Here I am passing the arguments 10 ff1 with packet. This 10 will be assigned to address. Okay. Next, ff is assigned to data, and 1 is assigned to bit write for this. Okay. Then packet type, good packet is assigned for packet type. After that, I just call the display method, which is present inside the packet pkt.display. So here I am calling this new, and I am passing the arguments, and these arguments are assigned to this dot address, this dot data, this dot write, this dot packet type. So this will be assigned to these variables, and those things I am displaying with the help of this display. So whatever the value I passed, those things I will get in the display. So here 10 ff1 good packet. Now if I didn't use this keyword, now I didn't mention this. Okay. Let's see. The compiler will not recognize the addresses, which address, whether it is input address, input argument which is sending that address, or actual argument property which is present inside the class. Okay. So that compiler will not able to recognize that, so we will get its default values. Okay. So when you use this argument and these properties as the same name, you should use this keyword. Okay. And class constructor. Class constructor is nothing but new of. Okay. So here class packet, I have properties like address and data. Here I instantiate packet as pkt1. Then I create a memory for that pkt1 with the help of new constructor. When you call this new of pkt1 equal to new of, a physical memory will be allocated for that. Okay. And the variables, which is variables in the sense properties, which is present inside the packet, inside the class, will be filled with its default value. So address and data are bit 31 is to 0. Default value is 0, right? Okay. So in this example, while creating new constructor, you can able to pass the arguments. Okay. So this one we already discussed in the previous example. Okay, class packet, we have address and data. Here I want to override the existing new method which is present inside the class. So I need to write a explicit new method. function new, okay, any function. Inside that, okay, while I call this new of, I want to assign the values for this variables, address and data. So I received A and B as argument. This A is assigned for address, B is assigned for data. Okay. After complete this class, inside the module, I instantiate packet as pkt packet space pkt1. Then pkt1 equal to new. Here in the new function, I have two arguments. So I pass two arguments 10 and 20. 10 is assigned for address and 20 is assigned for data. So when I call this, a physical memory is created for that, and the properties will be filled with its default value, which I am passing here, 10 and 20. Here the same example which we discussed earlier. We have a packet and these are the properties, and here explicitly I wrote a new constructor method, so it will be override the existing new. Here I mentioned its a value for address is 10, data refer, write 1, packet type good packet. Okay. So when I create the new, when I call this new off, automatically this function will be called here, so automatically these values are assigned to its properties. Okay. See here, values are assigned. This static class members. The class members with the keyword static are called as static class member. Okay, we can use this static for a property or a method. Static data type, you can use any data type, and property name, static, function, task, method name. Class can have static properties and static methods. A single copy of static variables will be shared across multiple instances. Okay. That means when the use of a static is, it will be created a common memory location for this property. Okay, when we use multiple instance, okay, so multiple instance of a class, okay, the variable which you declare as a static, that is common for all the instance. Okay, that is the beauty of static. Okay. A physical memory will be, a constant physical memory will be created initially. Okay. So it is common for all the instance throughout the simulation. And one more thing, static class properties and methods can be used without creating an object of that type. That means if you call new of, at the time only a memory is created for that class. So you can able to access the properties and methods after you create a new of. But when you declare that as a static, so a memory is created. So without creating the object, that is without using the new of method, we can able to access the properties or the methods. Okay. Let's see an example. Okay. Here, this class packet has a property, two properties are there. One is packet ID, it is a byte type. Another one is number of packet created, it is also a byte type. But I declare this property as a static. So a common memory will be created for this number of packet created. Now inside this new of, what I am doing is I am incrementing the number of packet created. Each time when I call this new in this module, okay, after creating the handle, I'm going to create object, right? So each time when I call this new of, this number of packet created is going to increment. Defaultly this is a byte, so the default value is 0. So when I call one time this new of, the number of packet will be incremented by 1. So in the next line, I am going to assign this number of packet created to packet ID. Okay. Then in function display, I display the packet ID. To this value I'm going to display. Now inside the module, I instantiate pkt of 3, packet pkt of 3. That means here I created 3 instances. One is pkt of 0, and one is pkt of 1, comma pkt of 2. So we are creating 3 instances. Then within the initial block, I use for each row. Inside I have 3 packets, right? So 3 times it will execute. Pkt of 0 equal to first time, pkt of 0 equal to new. So pkt of 0, it calling the new constructor. Okay. So at the time number of packet created will be 0. It is getting incremented by 1. Okay, that 1 is assigned for packet ID. Then pkt of 0 dot display, you will get the display like this. Okay, packet ID 1. And in the next iteration, pkt of 1 equal to new. So pkt 1 instance is calling the new. Okay. So at the time also the pkt, this number of packet created, is a static. So this variable number of packet created is common for all the instances. For pkt of 0 and pkt of 1 and pkt of 2, all are sharing the common number of packet created variable. Okay, common constant physical memory will created for this number of packet created. Okay, each time when you call or access this number of packet created in all the instance, okay, it will pointing to the same location. So when you do second time pkt of 1 equal to new, so at the time this number of packet created, the already stored value is 1. Okay, it is get incremented. Now number of packet created is 2. So that is number 2 is assigned for this packet ID. So when you call this display, so it will display packet ID as 2. And in the next iteration, pkt of 2, so pkt of 2 equal to new of, so already value 2 is there, so again it will get incremented by 1. So 3 is assigned for packet ID. You are getting packet ID as 3. Okay. If I didn't use this static, now the packet number of packet created properties different. That means pkt of 0 have its own number of packet created property, and pkt of 1 have its own number of packet created. Pkt of 2 have its number of packet created. So all has different memory locations. Okay. So when I run this, default value of number of packet is created of pkt1. Okay, so you will get 1 packet ID as 1. And for pkt2, number of packet created is default value is 0 because that is in different memory location. And pkt of 2, that number of packet created is in different memory location. So each time it is accessing from its own memory location. Okay, but when I use static, a common memory is created for all the instance only for this particular variable. Okay. not all the variables. Whichever the variable you are declared as static for this property or a variable, it is common for all the instances. All the instances are accessing from this location only where it is created. Next is class assignment. Here we are going to assign a handle of one class to another class handle. We are just assigning a handle to one handle like this. So here in this example we have one packet, class packet. It has an address and data. This packet I instantiate within a module. I instantiate this packet as a pkt1 and another handle or another instance pkt2. Okay. Now I am creating or building a memory for pkt1 alone. So pkt1 equal to new. So for pkt1 address is created, the properties which is present in that pkt1 filled with its default value. Now pkt2 equal to pkt1. It means pkt1 we have one handle, pkt2 one handle is there. For pkt1 alone I created a memory for pkt2 equal to pkt1. That means pkt1 handle is assigned to pkt2. So now pkt1 and pkt2 both are pointing to the same memory location. Just 1, 2, 3, 4. Okay. Now if I vary a variable in pkt2, that will affect in pkt1 also because both are pointing to the same memory location. For example, pkt2 dot address equal to 10. Okay, so it will change. pkt2 dot address will change to 10. When I display pkt1 dot address, that value will vary. So both are pointing to same location. So when I change in pkt1, it will affect in pkt2. If change in pkt2, that will affect in pkt1. So here in the packet class, I have these properties, and in new constructor, I assign the default values for each properties. Then this display to display the values of each variable, and inside the module, I instantiate packet as pkt1 and pkt2. Okay, I created new for pkt1 and I am displaying. So I will get its default value, right? So these values I will get 16 ff display with the decimal. So these values are assigned for pkt1. After that, I am doing class assignment pkt2 equal to pkt1. After that, I display pkt2 value. So the values are same. Whatever they are in pkt1, that value is same in pkt2 because both are pointing to the same memory location. Now in 42 line, I change the address value as 56 in pkt2. After that, I change the address as well as I change the packet type as bad packet. After that, I display packet1 display. I change it in pkt2. I change it in pkt1. So it will take effect because both are pointing to same location, right? So let's see. We are getting 56. We are getting bad packet. It is very. So this is called class assignment. Then we have two methods of copy. One is shallow copy and deep copy. Shallow copy, the sense, this is the general syntax for doing the shallow copy. Destination handle equal to new source handle. So in the class assignment, okay, when you change a variable name in a particular class, that will affect in the another class, because both are pointing to the same memory location. Okay, but in shallow copy, what we are doing is we are creating a new memory and we are storing the data to another handle. Here, this is the source handle. Okay, this is the destination handle. I created a new and I put all the values present in this source handle to destination handle. Now, source handle pointing to different location and destination handle pointing to the different locations. Here we have certain limitations, like we can able to copy only non-object properties to the new memory location. The non-object properties in the sense like normal properties, those things. Non-object means that is called nested objects. Okay, we are instantiating another class within this class, that is called object properties. Okay, object properties only handle get copied. So this is the limitation of this shallow copy. Okay, for non-object fields, different memories is shared, but for the object field, same memory is shared. Okay, that we will discuss with the example. So this is the general syntax. We'll understand how shallow copy is happening. Okay. Packet 1, packet 2, two handles are there. For packet 1, I created a new and I assign the values for address and data. So address and data which is present inside the class packet. Okay. Now I have filled values for address and data. So when I call this new memory will be created, it will load with its default value. Here I am assigning values for address and data for packet 1. Now inside the module, I create another handle as pkt2 as a packet type. pkt2 equal to new pkt1. So what it means, a new memory is created for pkt2 in this location. Okay, and whatever the content which is present in pkt1, that is copied to pkt2. So address and data are stored. Okay. Now if I vary the address and data which is present in pkt2, that will change here itself. For pkt2 only it will change. It will not affect for pkt1. Okay. So this is called shallow copy. I already told you the limitation. Okay, that we are going to discuss now. Okay, the drawback is object properties only handle get copied. Okay. So that is the drawback. For non-object properties that we discussed here. Okay. Different memories are created and we can able to copy those things. Object property in the sense nested handle like this class address range. Okay, it is a class address range is a class. Inside that we have a source address and end address. So this class I instantiate within another class packet. Okay, within this class packet I instantiate this address range. Okay, a class within another class, and you can say a nested class. This handle address range ADR, it is the handle for this address range. Okay. Here within this packet we have address and data properties, and in the function new So what I am doing is I created a object for this class, address range class. Okay, when I call new of for this packet, click here. Okay, packet 1 equal to new of. Okay, packet 1 is nothing but a type of packet class. Okay, when I create a new of, automatically it will create new for this class. Okay, so when I create like this, so for a packet 1, separate memory will be created, and the properties which is present inside the pkt1 will be filled with its default value. Okay, so this new constructor calls the new constructor of this address range class. So automatically for address range, for this ADR, another memory will be created and it will be filled with its default value. So it is a bit, right? So our start address is 0 and end address is 0. Then here I am doing shell of copy pkt2 equal to new pkt1. So if I do like this, another new memory will be created for pkt2, just this one. Okay, so this address is 1 2 3 4, this is ABCD, and here 5 6 7 8 is this address location is created for pkt2, and I call new. So packet 1 content is copied to packet 2. So packet 1 we have this content, address and data. Okay, that is copied for packet 2, but the object properties, this ADR is an object property that shared the same address. For pkt1, ADR is pointing to this location. It's nothing but ABCD. For pkt2 also shared the same location for the nested handle. Okay, it also pointing to the ABCD location. So this is the drawback or limitations of shallow copy. Okay, when you change pkt2 dot ADR dot S address, it will affect the pkt1 also. Okay. This is the class address range class. Okay, here we have start address and end address, and in function new I assign value for start address and end address. Okay. And I call new constructor for this address range. Automatically address 1, sorry, start address 10 will be assigned, and for end address 50 will be assigned. Inside class packet I have two properties, address and data, and I instantiate this address range class here. This address range class is instantiated as AR. Then this new constructor for this class packet, when I call this new of in the module, so for address it is assigned as 10, for data it is assigned as FO, and I am creating new constructor for this AR. Then the display, just display the values of address, data, and start address, which is present inside the AR handle, and end address also, which is present inside the AR. Then in the module part, I instantiate packet as pkt1 and pkt2. Now I call pkt1 equal to new of. Okay, so it will call this new method. So address will take this and data will take this, and it is calling the new of address range. So this address, start address will take this 10 and end address will take this 10, 50. So after this, I am calling the display. So all properties are assigned with its default 10, FF, 10 and 50. Now I'm doing shallow copy. I created a new PKT1. Okay, memory will be created for PKT2 and the content of PKT1 is copied to PKT2. Now if I display it, the same value to have in PKT2. Okay. Then I change the address and start address and end address. Okay, already we discussed only non-object property, a new memory will be created and it is copied to PKT2. For an object property, it is sharing the same memory location. So when you change the address of PKT2, it will not affect PKT1 address. Okay. But if you change the start address and end address of AR, okay, which is present in PKT2, it will affect in PKT1 also. Okay, after that, I display PKT1 that display. You see here, I change it in PKT2, but in PKT1 also it is get changed, but it is not changed, right? Because both are pointing to different memory locations. Okay, only the object properties of that object are pointing to the same memory location. So when I change in PKT2, PKT1 also it changed. Again I print in PKT1. Okay. I changed this one, right, in PKT2. Okay, display in PKT2. Okay. So this 68 I assign for PKT2, so it will not affect PKT1. Change it in PKT2. So this is the drawback of copy. We have a drawback that object property share the same memory location. Non-object property share different memory location. Okay, so object property is nothing but a nested handle. Okay, a handle of another class, that is called object property, and non-object properties are these fields of a class. So in deep copy, we are overcome that by creating a copy method. Inside the method, we are creating a new memory location for another object, and we are going to copy one by one to the destination object. So one example you can see here, we have one class. Address range is one class, it containing start address and end address. Here we have a copy method. This method is a type of address range. That means this copy can contain a start address and end address because it is a type of address range. So for this copy, we are creating a new, and we are copying the start address of a particular instance, from which instance we are calling this copy method. That instance start address is assigned to copy dot start address. Similarly, that instance end address is assigned to copy dot end address. Then we are returning this copy method. Okay. Now this address range is instantiated into another class that is called packet. Okay. This class we are creating. Inside that, we are instantiating this address range class as ad_r. This packet has the address and data. Here we are writing this new constructor explicitly. In that, we are calling the new constructor of address range. And here we are creating a copy method. It is a type of packet. So if it is a type of packet, this copy has address, data, and address range. So for this copy, we are creating new, and this dot address, nothing but from which instance we are calling this copy method. That instance address is assigned to copy, it containing address, right? For that it is assigned, and that instance data is assigned to copy dot data,
And similarly, so that instance has this address range. From that, we are calling this copy method. It will call this copy method, and the assigned address, start address, end address is written here. That is assigned to copy dot address range. And finally, after performing this, it is returning this copy type of packet. Okay. Now this packet is instantiated as PKT1 and PKT2. Now for PKT1, I am creating new. So when I call this new of, automatically memory will be allocated for this address and data. Okay. And here we are calling internally this address range new of. So it will call this new of method for this address range. So another memory is allocated for this start address and end address. Now here we are doing the deep copy. PKT2 equal to PKT1 dot copy. So here I am calling the copy method from PKT1 instance. Okay. So PKT1 instance copy here I am calling. So PKT1 start address, address and then data, that is assigned to for this copy address and data. And PKT1, it has the address range instance. From through that it is calling this copy method. So the address range which is present in PKT1, that is assigned to copy dot start address. That end address is assigned for copy dot end address, and it is returning this copy. This copy is assigned to copy dot address range. Finally, all these value are written here. That is assigned to PKT2. Now a new memory is created for PKT1 and PKT2 for the object property and as well as non-object properties. Okay, so these are object property, and here this is for non-object property. We will see one example. The same example. Here we have that address range class. Okay. Here I write this new constructor explicitly, and I assign some default value for the start address and end address. Here we write that copy method. Okay. And inside this packet class, we are instantiating this address range as AR. Okay. And here, this new constructor, I am filling with some default value for this address and data. Okay. So when I call new of, automatically this address will take 10 and data will take FF, and it is called, it's a new constructor for this handle, and this is filled with 10 and 50. Start address is 10 and end address is 50. And we have one display method to display the corresponding address data and start address and end address of a particular instance. Here we have that copy method. So this copy is a type of packet. So for this we are creating new, and from which instance we are calling, that address is assigned to copy dot address. The data is assigned for copy dot data, and this AR dot copy will call this copy method. So it will create new memory, and start end address are assigned here. That is written here. That is assigned to copy dot AR. And after performing all this copy method is written. Okay. So in this module, class assignment, we create two instances, PKT1 and PKT2 is a type of packet. And here we are creating new for PKT1. So automatically the fields are filled with its default value. And we are calling PKT1.display. So this display, you can see all the fields of a class. Okay, and the nested class handle that has a start and end address. Okay, everything is filled with its default value. Okay, after that, here I am doing deep copy. PKT1 dot copy. Okay, so what will happen? All these fields, new memory will be created, and then these are assigned to PKT2 that field. Okay, and then that nested handle AR. Okay, through this PKT1 has 10 and 50, right? That is assigned to PKT2 start address and end address. Okay, so we are getting here by calling PKT2.display. Okay. Now I am changing the value in PKT2. Okay, it should not reflect in PKT1. Okay, We will check here. Okay, for PKT2, I am changing the value. Address I changed as 68, and start address and end address I changed 60 and 80. Okay. After display this PKT1, after changing this, I am displaying PKT1 and as well as PKT2. Okay. So here you can see PKT1 holding the previous same value. Okay. PKT2 alone it changed. That means the object and non-object both are pointing to different memory location. Okay, so if we are changing PKT, it does not reflect in PKT1. Okay, that's all about tip copy.